hourglass? Could I put water in an hourglass and would I get the same timekeeping ability?
You could put water in an hourglass, of
But
course.
it wouldn't do me any good.
It wouldn't do you any good. It would not do the following. It would not be a linear keeper of time. In other words, what makes the sand here so remarkable is that no matter how high the filling height is here, the flow rate at the orifice is always the same. So if you had markings that tell you time, 1 minute, 2 minutes, 3 minutes, whatever, they are equally spaced. It has to do with the fact that most of the weight up here is unloaded not straight onto the hole, but it is going towards the sidewalls.
The weight goes to the sides? Hard to believe. Until Heinrich and Sid got my competitive juices flowing with a simple children's game. You really got my interest now. The curved bar, which is like gravity, pushes down on the wooden discs representing grains.
I see a space here.
The trick is to remove the discs that aren't holding up the bar.
This looks like it's free. Yeah, all right. Well, that's a big one. I got
Yeah,
points
so
there.
you're...
This looks like it's very much connected to, but this doesn't look like it's connected. There, I got another one.
Beautiful.
I'm pretty good. Now, this one I get for free. But it could be all the way down here. I could... I'm guessing this doesn't connect anything. Yeah.
Beautiful.
But this must.
That's right.
Now, that was really a force against the side, wasn't it?
Correct. And so we started with a force coming down this way, but we ended up with a force against the wall. So the material diverted the force against the wall, and that is why the hourglass has this constant flow rate, because much of the forces from all the material above the orifice gets diverted against the walls.
So mild, you know. So
One of Sid Nagel's favorite trivial questions confronted him one day from his kitchen counter.
Are these historic coffee stains here? Are these the ones that gave you your inspiration?
No, they're a day old or so, but when they're lovely as this, wouldn't you have trouble wiping them up?
Yes, it's true. Sid really does find coffee stains beautiful. Because they made him wonder why, when a coffee spill dries, it always leaves a ring.
So, this is where...
Enough of Sid's colleagues took the question seriously that experiments began to watch what happens as a coffee spill dries.
So, Rob here has been
Nice to meet you.
looking under a microscope at some of the drops where instead of using coffee, we've used particles that you can actually visualize under microscopes.
I'm seeing a lot of particles moving from over here to the edge.
The question was, what's causing this flow? The answer hinged on the fact that the edge of a spill becomes pinned in place by tiny rough spots on the surface, so the edge can't pull back as the liquid evaporates. As the edge loses liquid to the air, it has to be replenished by liquid from within the drop, and the flow that results carries with it the tiny suspended particles.
Is this white band particles that have built up
That's
on
right.
the edge
Yes.
already?
That's right. And so you see how slowly and carefully they come in there and they pack very nicely into a very well-packed, almost crystalline ring.
The careful packing means that even this humble discovery could have unexpectedly useful consequences. For instance, in manufacturing ultra-fine wires and electronic circuits. So even in coffee stains, there can be inspiration.
It's really interesting that this kind of a stain from a few drops of coffee has probably shown up on countless millions, thousands of millions of countertops.
On my countertop alone, it's shown up that many times.
And many of those countertops were the countertops of serious, curious scientists. And yet you and the people you work with took these stains seriously, and you thought something can be learned from that'll lead us to a deeper understanding of things other than coffee stains.
So I have this kind of broad view of what physics should be. And it's not just building the great big new conducting super collider or the great new Big Bang theory of the universe, but it's also trying to understand phenomena such as this that really gives us the texture and the feel of our daily lives, which is important to understand.
It seems possible then that by studying things like coffee stains on the countertop and sand in an hourglass, or nuts in a container of mixed nuts, really can give you some insight into the way the whole universe is formed.
Which, if you'll recall, is just where we came in.